Okay, let's now start with chapter 10. Now, I would say for the most part, chapter 10, at the beginning of the chapter 10, it should be pretty straightforward. Now, if anyone finds some material to be challenging, and I would say the calculating for the total risk is definitely a challenging part to most people. Fortunately, in chapter 10, we're starting a little easier. Okay, we're gonna start with just one asset at a time. While in chapter 11, we'll have to calculate the total risk when you have a portfolio with multiple assets. But chapter 10, it will get you started with only one asset. Then we'll talk about how to calculate variance and standard deviation when you have whether historical data or projected information. The calculation will be a little different, okay, and you need to know them. All right, so let's start from the top. Those are the topics that we will cover in chapter 10. We'll start with some basic review of Finance 330, how to calculate dollar return, and how to convert that dollar return into a percentage return. So while the words percentage return is commonly used in most introductory textbooks, but more appropriately, this percentage return is called the holding period return. Okay, so we're also talking about how to calculate the holding period return and how to decompose it into dividend yield versus capital gains yield. So once we know how to calculate the holding period return for one period, then we can do that for many periods, right? So let's say we can calculate holding period returns for many years, one for 2019, one for the year of 2018, and one for the year of 2017. So we can have many holding period returns calculated, one for each period. So now with multiple holding period returns, we can now look at the multi-period return. So how do you calculate the arithmetic average, which is simple because it is just the simple average across the multiple periods. But we're going to see that in the real world, our returns are actually compounded through time. So if when you have multiple periods, when you hold on to an investment for multiple periods, how do you actually measure your wealth change? By taking compounding into consideration. So that will be, done by using the buy and hold return. But what if you don't want to know over a 4-year or X number years of period, what is my overall return? What if you want to calculate your average return by taking that compounding into consideration? Well, in that case, you have to know how to calculate your geometric average return. And I'll show you all three of them, okay? Then after that, we'll talk about, well, by looking at the actual historical returns in the US history, we classify different assets into different portfolios or different categories, and we calculate their returns and their risk. Then we compare the different portfolio based on the different risk level, and we're going to see that these two variables, risk and returns, actually have a positive relationship in the long run, which means that the riskier assets tend to pay higher returns in the long run. And that's because investors are risk averse. We do not like risk. Therefore, in order to entice investors or to motivate investors to invest in riskier projects or in riskier investments, we have to pay investors higher returns. Okay, and we see that historically speaking, that is true. Okay, we find that riskier assets tend to earn higher returns in the long run. Then after that, we'll also decompose the holding period returns into risk-free rate and risk premium. Well, that calculation is going to be really simple, but the purpose of calculating for the risk premium is so that we can control for the risk level while comparing the different performance. Let's say fund manager of A versus fund manager of B, which one performs better? If A earns 10% per year in the past 10 years, while B earns 15% in the past 3 years, can we necessarily say that B has outperformed A? No, we can't quite say that because B potentially earns higher return because it has much higher risk. Okay, so we need to know how to look at the risk premium by controlling for the level of risk that is precise to that particular investment. So we're also talking about how to calculate the reward to risk ratio, also known as the variability ratio, okay? Then the tough part of this chapter is to actually calculate total risk, which is measured by variance and standard deviation. So variance basically measures the volatility in returns across time, while the standard deviation is just the square root of your variance. So in order to calculate your standard deviation, you need to first of all calculate your variance. And how to calculate the variance of an asset, it depends on whether you have historical return, which is actual return information from the past, or whether you are trying to project into the future when historical return information is not reliable or unobtainable. So the calculation method is different. Okay, in the very last section, we'll talk about Fisher effect, which basically examines the relationship between your return, your actual return, and inflation. Because the truth is that when you earn 10% return on an investment, your purchasing power does not increase by 10% because in the real world, we have inflation, which weakens your purchasing power. So even though you may earn 10% return at the surface on an investment, but it doesn't mean that your purchasing power goes up by 10%. Okay, we have to take that inflation into consideration when solving for your real rate of return, which measures your purchasing power. Okay, I know that's a lot of information, but we'll go through all the details as we, are there. So let's start with the top, dollar return and percentage return. How do we calculate them? So dollar return has two components. The first component is income, while the second component is your capital gain. Your income is just, for example, if you work, whether you earn money through wages or salary, that will be taxed as your ordinary income. Or if you work as a waiter or waitress, the tips that you receive will also be taxed as ordinary income. Now, from the investor's perspective, if you invest in stock and you receive dividend payments, the dividends are taxed as ordinary income. Now, if you do invest in bonds, when you receive your coupon payments or income payment, interest payment, that will be taxed also as ordinary income. So examples of income will include dividend, coupon payments, wages, tips, and salaries. Okay. Now, capital gain, it measures the price appreciation. So if I invest $100 on a share of stock and few months later or a year later, the stock is now traded at $110. Then my capital gain, which measures the appreciation in price, it will be calculated as the $110 of my end price minus the $100 of my begin price. In this case, my capital gain is $100 because the price appreciation on my investment is, $10. Okay, it's $10. So 110 minus 100 gives us the $10 of capital gain. Now, why do we also know how to calculate the holding period return? Well, this is because, let's look at this comparison, okay. So let's say that we have two investments, okay, A versus B. If investor A earned $100 in this period, while investor B or investment B earns $120 during the same period, can we necessarily conclude that B has outperformed A because it earned more money? The truth is that we cannot quite reach that conclusion unless we say that this is an all else being equal scenario. But again, in the real world, we will rarely run into the all else being equal scenario. So what we need to do is that we need to compare this earnings or a dollar return with respect to how much was actually invested at the first place, right? So maybe A earned $100 return or a dollar return that is based on $1,000 of investment. While B maybe earns $20 more, but what if that is based on a total of $2,000 investment? Right. So if you invest twice as much money in B than in A, then you really should earn twice as much money, right, in B. But that's not what we see. So in order to figure out which one has actually performed better between A and B, we cannot simply look at the dollar return without comparing that dollar return with respect to your P0 or your initial price of the investment. And that's what the holding period return or the percentage return do, okay? So if we divide your income, which is the first component of your dollar return, by your initial investment, also known as P0, your income is notated by D1, okay? So if you use your income and divide by P0, then that will give us the dividend yield, okay, which is basically your income divided by your investment or begin price. Now, capital gain, we know that's calculated as your P1 minus P0. So if you divide that capital gain also by the same P0, which is the initial investment, then it will give us the capital gains yield. Okay, capital gains yield. Now, when you add these two components together, then you will obtain this holding period return. Okay, so also we know you need to notice that since both the dividend yield and capital gains yield have the same denominator, right? We can basically merge these two components together, given that they have a common denominator. So when you merge the numerator, we end up having the numerator that looks like that. We have income, which is notated by D1, plus P1 minus P0, while denominator is just your P0. Okay, so let's look at this very simple numerical example together. So suppose you bought 100 shares of Walmart stock a year ago at $25 per share. It is the price that you paid. Okay, so this by definition, it is your P0 or your begin price. So over the last year, you received 20 cents in dividend per share. So notation wise, this dividend is our D1 or is our income. At the end of the year, the stock sells for $30 per share. So that's the end price notated by P1. So what do we need to calculate? We need to first of all calculate the dollar return before we calculate the percentage return per share. So based on what we discussed in the earlier slide, dollar return includes income and capital gain. So what is our income? In this case, the dividend that you received will be taxed as ordinary income. So dollar return includes D1, okay, which is income, plus P1 minus P0. So your D1 is just the 20 cents of dividend received, while your capital gain is your P1, $30, minus the begin price or P0 of 25. Okay, so if you're only being asked to solve for income, it is 20 cents. If you're only being asked to solve for capital gain, it is the 30 minus 25, which will be $5. But if you're asked to find the dollar return, then it will be the sum of your income and capital gain. And your correct answer will be $5.20. Okay, $5.20 per share. That's how much that you earned per share. But if you want to convert that dollar return into a percentage return, all we need to do is to divide the dollar return by the initial investment, which is your P0, right? That's what we mentioned here on the earlier slide. Where we just need to basically, we have just calculated this numerator here, which is the dollar return. And we just need to divide it by the P0 or your initial investment. And that will allow us to convert dollar return into the holding period return. And that's what we will do here. This is our dollar return. We're divided by P0 of $25 per share. So that will give us a holding period return of 20.8%. Oops. Okay, 20.8%. I'm at the edge of the screen, so it's hard to write. Okay, 20.8%. Or if I bring up my calculator, I can plug in 5.2, $5.20 in the numerator, divided by $25 as my P0. Okay, so 20.80%. So next question is, what is the dollar return and percentage return for your total investment? So we're solving for the same thing, but rather than per share, okay, we're going to solve for the same thing, but by looking at the whole investment, your total investment that will include not just one share, but 100 shares of the stock that you invested. Okay, so your dollar return in this case, you will be of the total investment, you'll be calculated as the dollar return per share times the number of shares that you own. Okay, so if your dollar return is $5.20 per share, or multiplied by the 100 shares that you purchased. So it will give you a total dollar return of $520. But your percentage return is not going to change. It should be the same 20.80%. Okay, so if you're not so sure, you can still do the calculation if you wish. Okay, for the total investment, well, then I have to use this $520 as my numerator, and I divide it by, in the denominator, I'm going to use the P0 per share. Well, let me see if I can write here, 520. That's my total dollar return, and I'm going to divide it by my total investment. What is my total investment? I paid $25 per share and I bought 100 shares. Okay. Oops. So 2500 should be my denominator. Okay, so 520, and I divide it by, open parentheses, $25 per share times 100 shares that I bought. Right, that will be my denominator, total investment of 2500, and therefore it is still the same 20.8%, whether we're looking at a total of 100 shares or based on just one share. Okay, so it's always 20.80%. Okay, so now we have reviewed how to calculate your percentage return or holding period return per period. So assuming that we have done this for multiple periods, okay, in the past. So let's say we have calculated for the holding period return, one for year one for year two, one for year four, and one for year three, and one for year four. You can also call this as your R1, okay? R1 is 10%, your R2 is negative 5%. When you make money, your return is positive, right? When you lose money, your return is negative. So your 20% will be your R3, return the third year, and this is your R4, which is the return in the fourth year. So if you have to calculate for the arithmetic average, then it's very simple. Okay, arithmetic average is just your simple average. Yeah. Okay, arithmetic average is just your simple average. And how do you solve for simple average? We add all of the returns together, then we divide that numerator by the sample size. So here's the equation. Right? We add all of the returns together in the numerator, and since there are 4 observations, then to find the average, I will divide the whole thing by the sample size of 4 observations. So the calculation should be very simple. You should not need me to plug in the numbers into the calculator for you. But let's talk about the problem with arithmetic average by using a very simple and very obvious example. Okay, so I have to make it really obvious in order for you to see the problem of arithmetic average. So let's say that you invest $100 in year 0. Okay, then you earn 50% return in year 1. That means your R1 is positive 50%. Then you lose 50% in year 2. That means your R2 is negative 50%. Then after this, how much money do you still have left by the end of year 2? So without any calculation, without a calculator, just think of this logically. You start with $100 investment, then you earn 50% return. So that means by the end of year 1, you have 50% more money, right? 50% of that will be $50. So by the end of year 1, you have $150 in your pocket. Now, so at the beginning of year 2, you now have beginning balance of $150. But you lose 50% of that $150. So that means by the end of year 2, you have only $75 left. Okay, $75 left, which means that in this total 2-year period, you have lost a total of $25 or 25% of your initial investment, right? So your overall return is actually negative. You started with $100 at time 0, and you ended up 2 years later only with $75. However, if you calculate the arithmetic average, if your R1 is positive 50%, while your R2 is, R2 is negative 50%, then your simple average, which is typically notated by the R bar, okay, you'll be what? Adding the two numbers together, 0.5 plus a negative, sorry, let me use the same notation here. So R1 is positive 50%, while R2 is negative 50%. So when I add these two together, R1 is 0.5, R2 is negative 0.5, and divided by 2 observations, my arithmetic average is actually 0% return per year, right? So that is very misleading because in reality, we know that we have lost a total of 25% of our money. We start with $100 in year 0 and ended up with $75 by the end of year 2. But the arithmetic average says your earning or return is 0% per year. So if I multiply the 0% per year by 2 years, it tells me that I have not earned nor have I lost anything in 2 years. Well, that is absolutely wrong based on this very obvious example. Now, just in case if you could not figure out what I was saying, how do we ended up with the $75 at the end of year 2? We can use what we learned or reviewed at the beginning of chapter 4, that time value of money equation, where future value equals to present value times 1 plus r to the power of t. So if I want to calculate future value in year 1, I start with present value of $100. I multiply by 1 plus R1, which is 50%, so 1.5. That will give me, by the end of year 1, I have $150. Okay, now if I want to calculate how about future value in year 2, we can use the exact same equation here, right? Future value in year 2, and now at the beginning of year 2, we have $150. Okay, then we're going to multiply by the same thing, the 1 plus r. Okay, so my R2 is negative 50%. So 1 plus negative 50% will give me 0.5. Okay, so by the end of year 2, I have only $75 left. Okay, so if you cannot think of that intuitively, you can always use the mathematical equation to calculate this. Okay, so which tells us that we have lost a total of 25% of the $100 invested, even though the arithmetic average tells us that we have not lost anything, right? 0% return per year times 2 years, 0% times any years is still going to be 0%. Okay, so that's misleading, but specifically, the arithmetic average will make you look better than you are actually doing. Okay, so the conclusion is that arithmetic average does not or it cannot accurately measure wealth change. It cannot accurately measure wealth change. Okay, to be even more precise, it inflates your wealth change and make you look better than what you're actually doing in reality, right? In this case, in reality, you have lost a total of 25% of your initial investment, but arithmetic average tells you 0% per year times 2 years, you have not lost anything at all, okay? It always inflates and make you look better than what you're actually doing. And this is why mutual fund managers in the real world, they prefer to report their performance by using arithmetic average because it's going to make them look better than what they're actually doing. Even though, you know, the one other reason is that if they report other form of average, such as the geometric average, which we'll discuss later, they can claim that not many investors know what geometric average is or how that is calculated. So if investors don't know what geometric average is, there's no point to report that, okay? So let's now look at other multi-period return measures. So how do we measure our wealth change? So earlier with the arithmetic average, we mentioned that arithmetic average cannot measure investors' wealth change appropriately. Okay, it always makes the investors look better than they're actually doing. So if you want to measure your how your wealth change across multiple periods, then you have to calculate what is known as the buy and hold return, which basically just takes the compounding into consideration across time. So how do you compound? Well, in chapter 4, and we just saw that equation again, future value equals to present value times 1 plus r to the power of t, right? And we know that this term here in the red circle is known as the compound factor. So that's how we compound. We add 1 to the r before you compound it across t periods. Okay, so you can simplify into this way. If your R1 equals to R2 equals to R3, okay, in that case, we can simply compound them across the multiple periods by using the t to the power of t. But in reality, if your R1 is not equal to your R2, is not equal to your R3, then you actually have to spend the actual equation this way. So we can say future value equals to present value multiplied by 1 plus your R1, then multiplied by 1 plus your R2, then multiplied by 1 plus your R3. Okay, so if your R's are not always the same, then you have to be specific by compounding the returns across time this way. Okay, and that's what the buy and hold return uses. Okay, rather than solving for the future value, it solves for just the compounded return. Okay, so we do not include here. Okay, we do not include here. We simply add 1. Okay, so this is the compound factor. Right, before we compound returns across time, we have to add 1 to each one of the r's before we compound through time. So it'll be 1 plus r1 compounded or multiplied by 1 plus r2, then multiplied by 1 plus r3 until all of your r's are taken into consideration. Then we're going to minus 1. Why do we minus 1 at the end? Because we added 1 to each one of the r's before we compound the r's across time. So at the end, we must minus 1 to get rid of this 1 that's inside of each parentheses. So if we go back to that numerical example, okay, you start with $100 investment, you earn 50% in year 1, and you lose 50% in year 2. Then what is your buy and hold return? So if your R1 is 50%, while your R2 is negative 50%, let's do this. So your buy and hold return will be 1 plus 50% will give me 1.5 times 1 plus R2. So 1 plus a negative 0.5, it will give me 0.5. Okay. So, but I need to minus 1. Okay. So if I simply, well, there we go. 1.5 times 0.5, it gives me that 0.75, right? 0.75, but I need to minus 1. So once I press minus 1, it will tell me that I have lost, this is a negative 25%. That means I have lost a total of 25% of my money. Okay, so negative 25%. And that's exactly what we saw here, okay? So you started with $100 at time 0 and ended up with $75 by the end of year 2. So you have lost a total of 25%, right, in the 2-year period altogether. And that's what this holding period return or buy and hold return calculates, okay? So just 1 plus R times 1 plus 2, and you simply compound all of that through time, then at the end you minus 1. But what if you don't want to know that over the 2 years total sample period, how much return that I earned together? What if you want to take that compounding effect into consideration, but you want to find the average return per year? Then what do? You're going to calculate geometric average. Okay, geometric average. So you can look through this. So I have an extra sample here. You can use those numbers to plug in a number to calculate for your buy and hold return. Okay. So let's now look at the geometric average return. Okay. So the geometric average return is just your average of the buy and hold return. So we have just talked about how to calculate the buy and hold return, right? The buy and hold return basically just compound your multiple returns across time. So that means we have to, first of all, compound all of the returns across time before we can solve for the average, okay? Because geometric average return is the average of the buy and hold return. So how do we compound? We compound this way, right? 1 plus R1 times 1 plus R2 times 1 plus R3. So as what we mentioned earlier, if R1, R2, R3, and R4 are all the same, this is the same as 1 plus R to the power of T, okay? So that's how you compound. But now to take average of the compound, rather than taking the power of T, guess what? We take power of 1 over T, and that's what we're doing here. Okay, once you have compound R's across time to solve for the average of your compound return, rather than taking power of T to do the compounding, we do the opposite. So we take power of 1 over T. Then at the end, we will again minus 1. Okay, then that in order to get rid of this 1, that we added to each one of the R's before we compounded the R's across time. Okay, so if I use the same set of numbers that we have been using, again, my R1 is 50% positive, while my R2 is negative 50%, okay? Then what would I do? I will plug in my geometric average as 1 plus R1, which gives me 1.5, and times 1 plus R2, so 1 plus a negative 50%, it gives me 0.5. Then now, that's the compound return. To calculate the average of the compound, I take power of 1 over 2 observations, then minus 1. So let's try with the calculator. 1.5 times 0.5 equals, now I want to take power of 1 over 2, or we can say take power of 2 inverse. So to take power of anything, we use y to the x key. And if we want to use 2 inverse, right? 1 over 2, that's the same as 2 inverse. I'll press 2, then inverse, which is the 1 slash x. Okay, then equals, then make sure that we still have to minus 1 at the end. So minus 1 here. So our geometric average return, it is negative 13.4%. Okay, negative 13.4%. So if I want to use this average return to calculate how much money I will have by the end of year 2, how do we do it? So for example, future value, again, equals to present value times the compound factor, right? So I start with $100 investment as the present value. So 1 plus the negative 13.4% as the R. So let me do that. 1 minus 0.134 to the power of 2 periods. You should give us the $75. Okay, and that'll be the correct answer. Let me see here. So 100 times, open parentheses, 1 minus 0.134. Okay, I have to use 2 parentheses. Okay, so round it off to the nearest cent, it will give us $75. And we know that that is the correct measure, right? Because based on our calculation earlier, if you start with $100 investment at time 0, you earn 50% in year 1, you lose 50% in year 2. By the end of year 2, you should have $75 left, and that is correct, okay? Now, for those of you who want to avoid equation as much as possible, unfortunately, to calculate your geometric average or buy and hold return or your simple average, you have to use the equation, okay? Now, as far as this part though, you can just use the function keys if you want, right? So if I invest $100 at time 0 as my present value, investments are cash outflows, and I do not add any more money, so 0 payment or annuity. Right, my return is negative 13.4%. So 13.4 negative is my IY. I invest for 2 years, 2N, compute for future value. Okay, you'll be the same $75 if I round the number off to the nearest cent. Okay, so if you want to use those numbers here to calculate for the geometric average, the numbers have been plugged in for you, and you just need to make sure to actually practice this on your own. Okay, so This is average. Okay, so to interpret that, it tells us that you earn an average of 9.58% return per year. Okay, so make sure that not just how to plug in the numbers, because the truth is that everybody can plug in numbers, but we need to know what that number means once it is calculated. Okay, so this is the average return per year, in this case, over the past 4 years. Okay, so our investor made an average of 9.58% return per year during this particular 4-year period, realizing a holding period return of the 44.21% is the overall return during the same 4-year period. Okay, so from now time 0 to the end of year 4, this is my total return, which is 44.21%. Okay, so that's how you interpret the holding period return from the earlier slide here. Okay, so let's now look at historical returns across different financial assets. Okay, just to prove that this world famous, very fundamental financial theory is true. So one of the most fundamental investment theory is called the risk return trade-off theory. That basically says that these two variables have a positive relationship in the long run, which means riskier investments tend to earn higher returns in the long run. And that's because investors are risk averse. It's only human nature that we want to avoid risk. Okay, and therefore, in order to motivate investors to invest in riskier assets or projects, you need to compensate them with higher returns. Okay, so you need to make sure that this is only true in the long run. Okay, long run means longer than a year, while short run or short term means 1 year or less. So why is this positive relationship only true in the long run, but not true in the short run? Because in the short run, when we look at only one period at a time, higher risk, it means that while an asset has higher risk, it means when it's doing a good job, you're going to end up with a very high, very positive return. Now, on the other hand, high risk also means that when it turns out badly, it is going to end up with a very, very negative return. Okay, that's where the risk comes from. It's that uncertainty, the very high volatility. When it's good, it's very good. When it's bad, you lose your pants. Okay, maybe not totally lose your pants, but you end up with a very low return. Okay, so in the short run, you can either end up with a very positive, very high R, or you can end up with a very negative, very low R, or very low return. So in the short term, we cannot predict the relationship between these two variables. However, in the long run, we can conclude that this positive relationship is true. Okay, so let's prove that. So we now look at the actual history in the United States, and we classify different assets into different portfolios based on the different level of risk. So between stocks here versus bonds here, stocks are riskier, okay, because stock prices are more volatile. There's more ups and downs and bigger ups and downs in stock price movement. Well, there's much smaller price movement and also less frequent price movement when you look at bonds. Okay, sometimes the bond price may not even change for multiple days at a time, while stock prices tend to change from 1 second to the next second. Right. Also, when you look at the price change, stock price tend to have more volatile and bigger price changes than bonds. And that big change creates uncertainty. Okay. So we know for sure that stocks overall have higher risk than bonds because of that price volatility. Now you can also say that, well, when it comes to being paid, who gets paid first? Bondholders are paid first, while stockholders, especially common stockholders have residual claim, while residual means leftover, which means common stockholders will only get paid after all of everybody else has been paid, including preferred stockholders. Okay, so the longer you have to wait to get paid, the more likely that you will not get paid at all. So since bondholders will get paid first, therefore bonds have lower risk. While common stocks, they are the last one, common stockholders are the last one to receive payments, and therefore it is most likely that they will not get paid. And from that perspective, stocks also have higher risk. So now between small stocks and large stocks, Small stocks have higher risk because they don't have as stable of cash flows, and therefore their price tend to change more drastically. And also small companies tend to have higher growth, and that also translates into higher volatilities and higher real returns. Okay. So U.S. Treasury bills. Treasury bills are sometimes simply briefly referred to as T-bills. Okay. Treasury bills or T-bills, those are short-term debt issued by our federal government. Okay, short-term debt issued by our federal government. And T-bills are also known as risk-free assets because in the United States, these are the safest investments. Okay, now our federal government, because it has the power to print money, and therefore when it promises that it will pay you the $10,000 by the end of this year, guess what? Even when it runs out of money, it can simply print more money, and therefore it has zero default risk. At least in the short run, okay, it is short-term debt issued by the federal government, which means that from the time that the T-bill is issued up until the time that the federal government has to pay you for that par value is going to be 1 year or less, okay? So at least we know that within a year, our federal government should still have the power to print money, okay? We cannot necessarily predict what is going to be 20 years from now, but since T-bills will mature in a year or less, then we know for sure that this should be the safest investment that we can find. And for that reason, the T-bills are also known as the risk-free assets. Okay, risk-free assets. RF stands for risk-free assets. And therefore, the rate of return that you earn on T-bills is also known as your risk-free rate. Okay, risk-free rate. So now after we have classified different assets into different portfolios, okay, we calculate their average return during this sample period from 1926 to 2004. That's just based on this study. And we find that overall that's true. Okay, riskier assets tend to earn higher real return. So if you compare bonds here, okay, their return and their risk, right? Total risk is measured by standard deviation. Okay, you can use either variance or standard deviation. Well, we know standard deviation is just the square root of the variance. Okay. So if asset A has higher standard deviation than B, then you should also have higher variance than B. And that's why you can use either one of these two statistics to measure total risk, okay? Even though the standard deviation is more popular than variance, okay? So bonds are safer than stocks. So when you compare their return, their average return, we see that bonds also tend to earn lower real return. Right? They are safer. So if you compare their standard deviation, we see that the standard deviations of bonds also are much lower than the standard deviation of stocks. Okay, so higher the number means higher volatility, higher uncertainty, and therefore higher, to be precise, higher total risk. Okay, and now between small stocks and large stocks, earlier we mentioned that small stocks have less stable cash flows, right? Less stable earnings and also higher growth. For that reason, they have higher return and also they have higher risk. So when you compare the standard deviation of small stocks versus the standard deviation of large stocks, we can see that small stocks are riskier than large stocks. And at the same time, they also earn higher real returns than large stocks. Okay, so these results here prove that what we concluded earlier with the risk return trade-off theory, okay, that riskier assets tend to earn higher real returns in the long run, okay, in the long run. Okay, so this concludes the first recording. Well, the next recording will be much more math intensive.